Okay, all right, let's wrap it up. You guys spend money, so we're good. Everyone is back. So I suspect, yeah, 10 minutes is probably more than suitable. I think that's good average gauging. So the last format. So now we had like a ancient commercial format which has certain properties but also limitations, and we have a more modern format, like the one we just talked about, the 3DS model. And one of the other formats that I want to just introduce to you guys, because it may or may not be something that's worthwhile having in the back of your head, is the X3D model. So, and the idea there is that in addition to having industry specified models or industry standards, de facto standards, we also, of course, the Web3D consortium, or any consortium that's involved with web standard, wants to have its own standards defined as well. And that should be usually most comprehensive, covering all the different aspects, meaning model loading, material management, including lighting properties, but also possibly interaction or modeling entire scenes, which is not something we have yet talked about, but we will. Probably not today, because it will be a bit rushing to do that. But the idea is that the X3D model is precisely an outcome of this, and it's basically based on the VRML model. And any guesses what that stands for?
Virtual reality modeling language?
That's right, correct. That's right, and you're spot on. In fact, but this is
I'm pretty sure you told us this in a previous
Damn,
lecture.
Did we talk about this before?
I think you mentioned it in
yeah,
the list
earlier.
of all the formats.
Yeah. That's right. In the early list of the formats, it's there. That's right. So it's a format from the 1990s. The idea was there at this stage because virtual reality is like every 10 years you kind of have this bump that people become keen in it again, and then realize, oh, it's still not kind of hot enough, and technology is not ready. Still not good, right? So we always forget about it for 10 years, and then suddenly, hey, what about it? So, anyway, so we'll see how that goes. Anyway, this was one of those victims that hadn't been really picked up because it was trying to specify that comprehensively, and instead a successor, a fully XML-based successor, was devised. Here there were some fixed format approaches that were not did not conform to web formats. And this is the X3D. It's ISO-ratified, so the idea is that it's ideally widely supported, and it's supported by pretty much all the browsers we use nowadays. So that's quite good. So if you start playing with this, you will find that you should get immediate output, and it goes beyond just looking at the model, but also thinking about interaction with it, right? So quite neat feature. Furthermore, it deals with one thing that we don't really consider in the OBJ model. We have dynamic loading, right? So we could do some sort of lazy loading or rendering, rendering the different components based on availability. That's one of the aspects as well. We look into file structure in a second, but before doing that, perhaps one thing to get a better feel about the extent of this format is that it comes in different profiles. Is there any other formats where we have different profiles we know about? No? Yeah, in the context of web standards, you oftentimes have different extent of feature sets that are supported. So developers can accommodate a subset of it. So just to be quickly standard conform, because if you have a huge standard that has extensive functionality, it's kind of an investment to comply with that standard. So the idea is to make the threshold for entry quite simple. And the idea here is that we have a set of profiles that just focus on basic interaction of model information, similar to the OBJ format itself, right? Which also just supports geometry, lighting, and some basic animations as well. So it's also supported here. Interactivity is the next higher level, where it's really about giving entry points and interfaces to attach sensors or user interfaces to interact with the model, in a given situation, but also be able to really read outside data as an input to produce some different output. For example, consume temperature readings and adjust your graphics on that basis, things like that. So kind of built into the model. here the fully immersive one, the idea is it's going beyond just the graphic representation interaction, like the haptic element, but also thinking about audio, scripting within games. So that's really more geared towards providing comprehensive modeling of, for example, a game. Yeah? So collisions are supported here, fog features and things like that. So it's really the 3D graphics that we have in mind. So we actually have a fully fledged feature set as well. And here it goes further. That's actually quite interesting. The full model also considers geospatial information, so you can load GIS files right into the framework and operate with those ones. It has you can model animated characters, so like NPC-like characters. So I'm not sure about the complexity of the behavior, but you can introduce them already into your model out of the box, right? So you don't. That's quite handy because since it all runs in a browser, you're kind of constrained with respect to how much bells and whistles you can attach. Of course, you can. It's integrated with JavaScript, so you can have event listeners for specific, user events, for example, and perform, modifications to the model itself or have outside effects. But the idea here is that you have a comprehensive way of modeling 3D applications inside the browser. So that's the idea. But let's look at the format, because I think it's good that you guys see another format in addition to OBJ, just for your, just to get a feel. And the standardization consortium is Web3D. And the idea is there that the standards focus not so much only on 3D graphics, but also emphasize the industrial use. So you can, use it in this kind of context, having display artifacts, 3D games, obviously. But for example, the medical imaging is pretty hot right now. That's one of the key features, as well as here CAD product design. You see all the different approaches. Just want to have a look at this one here. So this is standard for humanoid animation. Unfortunately, there's no demo of that right now, so can't really show that. But and they have a wide set of examples that just showcase the feature set. So how you can integrate it, for example, with virtual reality, but also how you can do realistic modeling of terrain, which obviously is kind of an involved exercise. I will try to open that. My machine may go down on that grounds because it's kind of involved. Kind of regret it right now. We'll see. Perhaps you hear that in a second. But it is actually quite featureful. So that would be full focus on detailed modeling, large modeling, and advanced compression modes. So the OBJ format is rather inefficient, right? Because it doesn't by itself do any sort of compression of the text data, which is a disadvantage compared to binary formats such as 3ds. But this one, for example, is I can think that's quite accessible. The obvious one, having a base model teapot, but also some navigation. So you see the representation of the different axes, and then you can actually directly interact with the model. That's the key idea there. And that interaction comes kind of out of the box. That was that. All right. Still-ish interacting. Of course, it boils down to your machine you're dealing with. So let's see if I can bring up the source code, because that's the most fun bit, is to inspect it based on. This one is a bit friendlier, I think. Oh, it's not friendly. Spit me out the source code. It blocks the right click. Right, that's where I'm. The thing with its two screens, still need to learn that. So, come on. Page source. There you go. Right. And that's basically the format you get here in this example. So it's a bit better. So HTML embedded, some style associations here, CSS, boilerplate, and then you have some function specification like callbacks that react to certain events. For example, if there's a change in any sort of translation, then this event handler is called and it actually applies it to the changes the value of a particular object, as you will see, and for different purposes. So the first one looks at translation, so shifting in space. The other one is rotation. The third one is rotation as well. The difference there is, I think it applies to the entire scene. And what the scene entails, we'll see in a second. So here's the actual X3D specification. So if you have a HTML file and you want to embed it, you just need to have a in the body you need to have this X3D element basically, and that allows you to define a given scene. And then we have the camera specification, from which perspective we're looking and what we're looking at. And then it consists of various here's the term, the element is called shape. And this is the element that is basically modeling. This example, that's the teapot. So we have a set of coordinates that make up the individual vertices. The normals are specified in here as well. And then here's the indices and how far the faces are basically composed from the individual coordination point. Diffuse color is attached to some material information. There's more space, so it's embedded as part of the shape here as well. And then you can have transformation groups. The idea is if you have a teapot plus something else, should it, transform, translate together, right? So that's the idea here. So you can group those in a nested fashion in this XML style format. That's the idea. So with given complexity. So that's the ground plate. That's yet another shape. So that's modeled here. You can also identify objects by name. Here's the scene. Where's the object? There's no example here. No. And yeah, basically the different operations, right? So, and this is modified based on the JavaScript information that you can perform rotation along X, Y, and Z. And it's directly reflected in code. That's the key idea here. In addition to what we have there, this example doesn't show a particular sophisticated shapes. We just see solid structures here right now. But I think I have an example of other structures as well. Give me a second. There you go. So this, for example, is just yeah, basically modeling text as well. So it's embedded as well. You can just yeah, show some text outputs. Welcome for responding. While X3D responds to my input, my laptop doesn't, so it's a bit confusing at times. But this using basically the idea of having a text element. Let's say here's some example where you specify a shape with reference to text, and then specify the string and material information again. And of course, you can have multiple of those different shapes in your scene, right? So you can compose a scene of those different components. That's basically the core idea here. So if we rerun that, I think that is locally stored. Yes, it is. So then you have that. Those are different shapes that are now totally ridiculously overlapping, modeled here. No material information attached right now, but those are the four shapes. For example, it's available box, cone, cylinder, and sphere. And text as well. So there's a lot of stuff that comes out of the box which you will need to manually do in OpenGL as of now, right? So there's a lot more expressiveness in the language itself, but it's a bit bloated, right? It's native XML specifications. Another thing I wanted to just point you to is the interactivity bit. So kind of interactivity is built in. So you don't actually need to necessarily specify, you just need to tell the system what should happen if, for example, a particular movement happens, what the modifications to the models are, which you encode using JavaScript. But that's one I wanted to show you, but where's my big model? Did that explode already? Or there you go. So let's see. Oh, it actually works better than I thought. So 6 frames per second, 7 frames per second, and you see, you may or may not hear that my fan is currently going a bit crazy. So it's actually quite involving. In fact, if you look at it, it involves 16 million points, right? So 16 million vertices. So if you want to write a rendering engine, that's kind of the benchmark you're kind of dealing with those kind of levels. So it's quite flexible in terms of what you use it for, right? So here's really about realistic terrain modeling or topological modeling that you can do with. Another more simple use case, here you saw some interaction, but also is including animation, right? So that's like super simple demo and how to do animation with this language, and it's actually very, very brief. So you obviously define a scene again. So a scene wraps all shapes that are involved. You have a transform group, which is here defined as ball. So here's the keyword. You need to remind me, I'm not empathetic. So that's the transform group, which includes one shape in this particular case, and that happens to be a sphere, simply a sphere, so no further specifications. And the interesting bit here is the animation specification. So in a time interval of 2, I forgot that one, is it probably seconds? Yes. You move the ball by default between given positions. So you move it basically back and forth along those coordinates here. So that's the key idea in this order. And I forgot what else. That's basically just defining the route, but I forgot the interpretation of the details at this stage. But the idea is that it's kind of super straightforward to do those simple models, but also you can interact with them. You can modify the behavior just by interact with the elements. Anyway, so that's part of the X3D specification that is kind of straightforward. You can quickly get going with small models, but the complexity becomes very high because of the everything is held in one giant XML schema, which is hard to manage. So you again better rely on tool sets to do that. The reason again why I'm bringing this up is manifold. Of course, the compatibility right now is very high. So if you want to just show a quick, nice model, you have the option to export into X3D. Probably you want to do that, right? Because you can just publish it anywhere and anyone can see it. Not sure about mobile phones. Probably works. Need to check it. Should work. But that's one of the appeals there. But we also don't know. Perhaps it's becoming more relevant for game development. No idea, right? So VML didn't cut it really, but this one may actually have a serious chance. So it's worthwhile just to keep an eye on it and perhaps play with this if you have the opportunity. Is there anything else I wanted to say? No, nothing particular. So cool. All right. There you go. Please come back. Yeah, good. And that pretty much concludes the introduction about 3D formats that I had in mind anyway. But here, just as an overview, the usual trade-off, features versus compatibility is the key thing here. And you see some of the formats that we discussed. So one of the earliest formats, the STL format, which is really about just specifying the mesh itself, right, the vertices and so on, and how they are linked up into faces. But the point is that there's not even an appearance specification in there, so you can't actually model real material. The OBJ model, which is a bit more powerful, again, we know we have the geometry and the appearance that we can model, but we don't have camera, lighting, and all those kind of elements. Certainly no animation, for example. And then increasing the advanced models that formats that have some of those elements here. That's right. So yes, and again, I mentioned that before. Some of the models support units in the mesh specification, so you have absolute values. So those modeling formats are quite good for industrial purposes, for CAD, for example, where it's really important to have explicitly specified units and accuracy. Most of them actually have just relative, either coarse-grained or relative mechanisms of specifying geometries and sizes, for example. So there's the and in fact, if you look at it here in terms of feature set, of course, across those categories here, X3D is really, fully fledged, the biggest piece, a complete specification, ideally, of what's available in the 3D format spectrum. So it goes also including animation, for example, which is not supported by the many of the other ones. We have lighting elements, we have built-in user interaction, and so on. So it's quite a bit of potential, but again, focus on web technologies. Personally, the only thing is it really boils down to processing speed, how efficient you can actually process or how efficient your browser engine will actually process X3D, particularly for more complex models. That will probably fundamentally decide whether it gets greater uptake. But again, we have this usual trade-off of features versus complexity, but also exchangeability. So models that are written in OBJ are very consumable by many other tools and frameworks because they're a subset of the feature set that's widely available. Good. So, in fact, this is pretty much all I wanted to talk about. Otherwise, I would have dug into a new topic, which is kind of confusing. So I'll probably not do that right now. But this was the what I had in mind to cover for this session to wrap up the 3D formats. Any thoughts, questions, or else?
What's the next topic?
Next topic would be scene graphs. But it's a bit affords a bit more motivation. And also, did everyone play with Lab 7? Did do Lab 7 and change the lighting a bit, modify the lighting, did object loading and so on? The reason why I'm suggesting to do that is once you played with Asymp and the way it loads the object in kind of a hierarchical fashion, it kind of builds up a tree structure. That's kind of the prerequisite to understand the scene concept. You got a glimpse of it here. Here in X3D, a scene was basically a collection of objects in a wider sense, right? So they were all positioned in a space. And the objects, the key difference here is between the simple object loader and the scene graph is that an individual object can have a reference to a parent element in the scene, right? So that's one of the key challenges. So for example, if I want to model my hand, for example, and want to model a translation, rotation, and so on, then it's dependent on my arm movement as well. So it's a secondary effect. If I, for example, shift or translate my arm, I will, the movement of my hand is implied, even though I don't want to explicitly model it, right? So that's the idea of building scene graphs to identify the dependencies. Jonas?
When you say object, do you mean object or do you mean mesh?
Oh, yeah, that's helpful. Yeah, that's a good point. I wasn't specific about this, that's right. So for this purpose, I think mesh would be enough. So, yeah. I mean, yeah, if you wanted to differentiate it, feel free.
Yeah, I think we should be clear.
Okay.
Fine. I don't know what's the answer, but I want it to be the same answer every time I talk about it.
Good. Okay, we'll make that also part of the next session. Good one. To clarify all that terminology. What are other aspects that we need to cover since we're on it? Mesh versus objects.
Versus scenes.
Scenes, yeah, right, that fits well actually. It's a good idea. So we can do all the abstraction levels. Sorry? Groups, that's right. Yeah, we'll see if we get examples so we can really distinguish them nicely. Yeah, so the groups is a bit of a confusing concept because it's not strictly hierarchical. In fact, that's not a good example, but whereas the scene-object relationship, for example, is hierarchical, right? The object is a member of the scene. groups can be overlapping, right? So objects can be members of multiple groups. For example, if you have the same transformation behavior, then a particular object could be in multiple transformation groups or in multiple material groups, right? So because they share the same material. So that's it's a bit more of an overlapping concept, and that's a bit more a format-specific interpretation, I guess, because it basically boils down to the features that are offered by the 3D format.
Group.
Anything else?
Group is super generic though.
Yeah.
It can be anything.
Exactly.
It doesn't. It's not useful for like deciding some strict like language of these things.
Yeah, unless of course you define group explicitly what it can be, right? Can individuals be members of multiple groups, or is it strictly a one-to-one relationship between that an individual can only be a member of one specific group as opposed to multiple, right? So yeah, that's right. And again, you're right. That's precisely what's happening. Different formats have different interpretations. Other thoughts? Cool. Anyway, I'll take this in for the next session because it really doesn't make sense to motivate this entirely as of now. So I'll probably stop at this stage, and feel free to ask questions or have comments. Any comments regarding X3D or experiences? By the way, there's a companion format that's called WebGL. Did anyone have a look at this? That's basically the web version of OpenGL. So you can write nearly native OpenGL code similarly and execute it in your browser. So it's probably worthwhile, particularly for the Linux fraction, to figure out whether their browser supports. We don't need that in an upcoming session, but I think it's still worthwhile to check whether you actually support it, so we can think whether this is something we can explore in the session. Oh, what? The GL test. So if you run get.webgl, the URL get.webgl.org in your browser, you should see the animated cube. If you do, then your browser supports WebGL. If it's static and it doesn't turn, then it doesn't. Then it's just an image representation. So so that would be the that would be the
Oh yeah.
Pretty.
huh?
Pretty colors.
Can we make this?
Yeah, that's something
Add that to the list over there.
Yeah. Yeah, I wouldn't even object. In fact, it's OpenGL. In fact, slightly. In fact, that said, it's slightly reduced in terms of its functionality because it's derived from the embedded systems OpenGL, so it has reduced features. But fundamentally, it's OpenGL. So, yeah, I don't. Let's see if we can see some source code here right now.
Have you been to Shader Toy?
No, I haven't. Is it
Check it out.
cool?
Context of WebGL.
It might run slow on your computer.
Everything runs slow on my computer.
It's
But it may also just be my 20 tabs that I have opened at any given time. So,
I might contribute to
it may not
Are
necessarily.
you memory constrained or GPU constrained?
I'm generally on this machine CPU constrained.
maybe close that one.
I don't want to. It's pretty nice. Anyway, okay, okay. I
Don't
get.
close any tab ever.
Always keep them, even between boots.
Oh, definitely do those. So I keep them between sessions, in fact. So I know what we looked at last time. Yeah.
Export them to other machines.
All right, shader error, cool. Ah, there you go. You have your voxel Pac-Man already here. Okay.
It actually renders everything here, so you have.
Everything is rendered live in WebGL.
Yeah.
So it can destroy, if you're on the overview page, it can destroy your PC, but so it's advised to just click on something fast.
Quickly, okay. That's cool. Let's see something. Yeah, because it's normal OpenGL or regular OpenGL, so it's kind of be comfortable. Let's see what we see. So Jada, that's more like debugging it here.
Maybe Hubble can show it on his PC since he has a beefy.
Yeah, cool.
system.
Just plug it in. It's a good idea. So there you go. But like you say, we probably should use yours.
1 FPS.
We're getting somewhere, right? I think I have the wrong machine for the right course. So yeah, all right, cool. So that's yours.
The cool thing is that
Can I plug in?
Yeah, just.
Yeah, but I don't have HDMI.
Oh,
Oh yeah.
that's tricky. Careful, you're leaning on the. Ah, you have VGA. That's cool. That will do. Sorry, stream. We're changing the presenting machine.
also on the shader tool, you have the actual shader on the right side, so you can see the code.
I just saw that glimpse before my machine broke down. So. All right, so
I'm not sure the
needs to be
Pac-Man actually works on my computer though.
Probably will.
Again, a shader error. But I can show off the others.
Is your VGA activated?
Hey, I also have shader error.
Should be, let's see.
I don't know where. Where?
Okay, activate the
Where?
How?
Requires version of.
Oh, there you go.
Should be.
Should be, but soon, maybe. Looking network right now.
It's working over here.
Oh, it's working. There you go. So
Okay,
there you go. Cool.
Yay!
So I hope the stream gets a glimpse of what's happening here. So it's
That's the Pac-Man.
we're seeing Shader Toy, the Pac-Man, which may or may not work.
Okay, let's look at some others maybe.
I'm also getting shader error.
And it's only shader, I think.
Cool.
That's the restriction on this page. So it doesn't have any additional
Features.
logic. So it's quite
Cool.
insane
Wow.
what they can
And you get the source code for everything as well.
So probably you can see a bit of a shader input, a bit of a source code, see how much effort it would be to develop it.
move it.
But
Yeah.
it runs actually quite nicely, 40 frames. That's pretty decent.
40 frames, damn it, you're beating me.
Well, how much do you have?
27.
27. You have the power plug in, that can make a difference.
I don't, but that makes a difference, yeah, I think so.
Right. So, wow, nice. So if we see the shader input, what do we have here on the right side? So that's the.
What's happening?
Thanks, code. It's somewhat involved, isn't it?
Yeah.
I mean,
It's a soft shadow.
but what is it doing?
That's right. So where's the main?
Where's the main? Yeah.
It's just turning into a ball.
So it's spitting out fragment color. This one here.
Yeah.
It's
So
fragment shader.
that's the fragment shader that we're looking at. That's right.
But is it GLSL? Or is it some other shading language?
No, it should be the same.
Oh, yeah,
It should be specified on the top anyway. If you go to the
Yeah.
top, you should find the version. It doesn't say.
Så nu gör vi Celtex som etymology. Liksom.
Some of them are interactive.
I think most of them are interactive. Try clicking your mouse and dragging this canvas.
Oops.
But then it has to be more code than just the shader.
Yeah.
Yeah,
Doesn't
so
seem to be.
Oh.
That's the input.
Yeah.
So we have uniforms. What is it? Resolution, time delta for the